All right, Algebra 1. We are ready to start Remote Learning 1. And this is what you don't see this screen. This is my edit assignment screen. But these are the, like, I guess, what the question is titled. So table to exponential function is the first one. And it looks something like this. So find the equation of the exponential function represented by the table below. Okay, so it says y equals. So we need to put something here that looks like an exponential function, which, if you remember, looks something like this. All right, so we can do this by looking at the relationship between x and y. So I'm just going to replicate this table on my whiteboard here. 0, 5, 1, 20, 2, 80, 3, 320. Okay. All right. So I see that when x is 0, y is 5. So 5 equals something to the 0 power? Well, anything to the 0 power is 1, right? So there's no way that this is this and that's it. Because anything to the 0 power is 1. Let's think about it maybe like this. This is times 4, times 4, times 4, right? And this is going up by 1. So it fits the definition of an exponential function, right? We are going up at a constant rate here, and we are multiplying by a constant factor here in our y values. So we can think of 5 as 5 times 4, sorry about that, 5 times 4 to the 0 power. And we can think about 20 as 5 times 4 to the first power. And we can think about 80 as 5 times 4 to the second power, 5 times 16. And we can think about 320 as 5 times 4 to the third power, 5 times 64. Okay, and if you wanted to check me on that, you could put in your calculator 5 times 64, and it would give you 320. All right, so I can basically see my function already. I know I need a y equals something. And I know I want it to kind of look like this, right? Our standard exponential form. Okay, so I need a y here and an x here. Y equals, and then an x here. Now, what number goes here? Well, it's the thing that's being raised to the exponent, right? So that's 4. And then what thing goes here? Well, it's the thing that we're multiplying by the thing going to the exponent. So that's got to be 5. So it's 5 times 4 to the x. Now, this isn't like, be careful, because when we enter it in our, we don't want to think of this as 20 to the x. That's not what this is. It's not 5 times 4, right? This is order of operations. We do exponents first, 4 to the x, and then we multiply by 5. All right, so let's put that in over here. 5, I'm going to use parentheses here, 4. And to enter in an exponent, we pull down our little keyboard, and it gives us this option here to put in an exponent of x. Okay, submit. Yes, cool. And then it gives you a little explanation. Well, I don't know if that gives it to you, but it does for me. It might. So there's the rate of change. It's by 4s, going up by 4. And, oh, this is a nice way to think about it. So when x is 0, y is 5. So they put that here. See, I like that color coding. That looks good. Okay. All right. So let's go on to the next one. So there's 5 of those. You're required to do 5 of them. Okay. And if you do 5 and you get some wrong, it's going to make you keep doing 5 until you get some right. Okay. Maybe. I'm actually just make you do 5 and then you just won't get a good grade on the assignment. But okay. I'm going to turn this way. Hopefully this looks better on your screen. Given the following exponential function, identify whether the change represents growth or decay, and determine the percentage rate of increase or decrease. Okay, well, we talked about this quite a bit. I'm erasing my whiteboard. Okay, so I'm going to write y equals 28 times 0.438 to the x. Okay. All right, now what we look at is the number that is being raised to the exponent, this b, right? This thing, if this is less than 1, it represents decay. If it's more than 1, it represents growth. Now, why is that? Well, because this, as a percentage, is less than 100%, right? If I multiply something by 50%, I'm taking like half off. So this, as a percentage, is 43.8%. And I don't know if you guys all remember how to do that. I'll just do a little side note here, 43. So you move this way 2 times, right? That's 43.8%. All right, another way to think about that is just to multiply it by 100. Okay. All right, so 43.8% is definitely less than 100%, which means this is a decay situation. So we go back over here, and we go to decay, and we do 43.8%. Oh, what did it want me to do? Oh, I'm sorry. I said it out loud and then I didn't really do it. Okay, so this is less than 100%, right? So it's 100% minus something is 43.8%. Okay. All right, and then what's this something? How did we get 43.8%? Well, to figure that out, you could just do 43.8. I'm going to do this in my calculator. Minus 100. And you take the positive version of that, 56.2. So 56.2%. So that's our decrease. Okay. Sorry about that. I confused you a little probably. All right, I'll sum that up. We'll sum it up. And actually, maybe I'll just do a new one that way you can see. Oh, good. The next one's a growth one, so we'll do that as an example. All right, to sum this up, it was asking us, is this growth or decay? Well, we see it's decay because it's less than 100%, but by how much? That's what it wanted to know, and that's what I screwed up on. But by how much is it decreasing by? Not this much. It's taking 100% and taking off this much to get to this. Okay, so we're decreasing by 56.2% to get this. Okay, so let's do a growth example and make sure we know what we're talking about. So this one says, given the following exponential function, identify whether the change represents growth or decay and determine the percentage rate of increase or decrease. Okay, this one's actually a lot easier to see. We can kind of see by looking at it. Times 1.06 to the x. Okay, we see here that this number is greater than 1, so that represents growth. Looks like I growth. Okay, greater than 1, so that represents growth. But by how much? Well, we have to think about how much more than 100% is 106%, right? So this represents 106%. 1.06 is 106%. How much more is 106% than 100%? Well, 6% more, right? We could just subtract 100, and that gives me 6%. And that's it. That's all it's asking us. So how much more is this? How much is this growing by? 6%. All right. So we go over here. Its growth is already selected there, and it's a 6% increase. Okay. Cool. All right. Let's go back. Find growth and decay percentages. All right. So this is level 2. So we just did this, find growth and decay percentages. We just did this, but this is level 2. And the reason why it's level 2 is because you have, it's not quite in standard form anymore, where the exponent is just an x. I'm rewriting this on my whiteboard. the exponent is no longer just an x. It has this number with it here. So this goes back to what we talked about, the exponent laws. And I'll remind you, remember when we have like 5 squared cubed? This is the same thing as 5 to the 6th power, right? When we have power to a power, we multiply those powers. And the reason why that is simply 5 squared is 5 times 5. And if we cube 5 times 5, well, that's just 5 times 5 again, and 5 times 5 again. So what this winds up being is 5 to the 6th power. Okay. All right, so remember that. All right, and then we're going to use that to kind of go backwards here. We're going to separate our exponent from the number part of the exponent from the variable, because what I want it to be is something to the x power. All right, so we can think about this as 1700 times e to the negative 0.074, like this, and then risen to the x, like that. Because isn't this the same? I mean, I'm just taking this number and I'm multiplying it by this. I mean, this is power to a power, right? We multiply the powers together. And that would give me this. Okay, and now I can just put this funky doodad in my calculator. All right, and I know a lot of you haven't probably worked with e that much, but just think of it like something like pi. It's an irrational number that, you know, it's a button on your calculator. And I don't know if you know the definition of e, and I won't go into that right this second. All right, so I'm going to find it, and I think it's, if you can see, it's this purple right here. See that? Or is it blue? I have bad eyes, and I'm looking in a weird light. But there it is. I hit second, and then that blue, e to the x. Okay, so e to the what? E to the negative 0.074. There we go. And that gives me this number. So I'm going to write that, a lot of it anyway, here. 0.92867, and then it goes on to the x power. Okay, so that's what we have so far, but now I want us to do the same thing. So now we kind of have the same situation as we did last time, and we have to figure out, is this growth or decay? Well, this number is less than 1. So this is decay. Well, how much less than 1 is it? That's what it wants to know. All right, and it does tell us to round to the nearest 1/10 of a percent. So let's first convert this into a percentage. So 0.92867 is the same, because that keeps going, is the same as 92.867%. Now, it wants us to round this to the nearest 1/10. So this is the 1/10ths place, yes. And this number is larger than 5. Well, it's greater than or equal to 5, for sure. So that means we round this number up. So this becomes 92.9%. Okay, now we want to know how much less than 100% is this. So, right, so 100 minus what gives me this? And again, you could just kind of think about this as 92.9 minus 100, and then take the positive version of that. So 7.1 minus 7.1. Okay, so this is decay, and we are decaying by 7.1%. Da-da-da. All right, and then it did the same thing we did. It separated this exponent into power to the power, right? Separate with power to power rule. Evaluate what's inside the parentheses. They actually rounded it to the same place we did. And then figure out, well, how much less than 1 is it? Well, it's 7.1 less, or 0.071 less than 1. Okay, onward. All right, recursive sequence function notation. All right, so we started talking about sequences near the end there, the last like week and a half or so before our indefinite spring break. Okay, so it says if f of 1, notice how I'm reading that, making sure you're all remembering function notation. This is not f times 1. But if f of 1 is 5, and f of n is 4 times f of n minus 1, find the value of f of 6. Okay, and I wrote that up here. All right, now remember n in this case represents which term we're on. So if f of n is the term we're on, then f of n minus 1 is the value of the term before it. So I'll give you just a little example just to make sure you're all on my page. Let's say the pattern is 2, 4, 6, 8, blah, 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 blah. Well, then f of 3, like this, f of 3 is 6, because that's my third term. F of 1 is 2. You see what I'm saying? So f of n minus 1, the term before it, f of 2 is 4. Okay? All right. So that was just to make sure you're all on my page. All right, now we want to figure out, and this actually won't be too bad. So this is the first term is 5, right? And then there's some more terms, and it wants to know, well, what's the sixth one? Okay, all right, well, we can do this. If f of 1 is 5, then f of 2 is 4 times the term before it, f of 2 minus 1. See what I did there? See how these numbers match? N and n, 2 and 2, those match because n has to be the same. I mean, it's the same number that we're using. F of 2 equals 4 times f of 1, right? 2 minus 1 is 1. So this term has to be 4 times the term before it. Well, what is f of 1? It's 5. So 4 times 5, which is 20. So I write that up here. That's my second term, 20. Well, if the next term is just 4 times the term before it, can't I just keep multiplying by 4? That's a little shortcut, but I'll show you just in terms of notation how you do that again. So f of 3, the next term, the third term, is 4 times f of 3 minus 1, the term before it, which is f of 2. 4 times f of 2. What is f of 2? It's 20. So 4 times 20, which is 80. Okay, so then I just write 80. And I can clearly see my pattern. That's f of 6. Sorry. There we go. All right, so this is times 4. This is times 4. This is times 4. What is 80 times 4? That's 320. What's 320 times 4? We can just go ahead and do this in here now. 1,280. Okay, and then what's f of 6? Well, it's whatever this is times 4. 1,280 times 4 is 5,120. Okay, let's put that in. 5,120. All right, and then you can see that they went through and did it for each one, right? So f of 4 is 4 times the value of the term before it, which is the third term. So the fourth term is 4 times the third term. Okay. All right. And there is the sequence there at the end. It's a geometric sequence. There we go. Geometric sequence. Looks something like this. Geometric sequence has a common ratio of 4. And that just means any term, if I divide the term before it, will give me 4. So, 320 divided by 80 is 4. 5,120 divided by 1,280 is 4. So that's our common ratio. Okay. All right, and if you're trying to go ahead and fast forward through these to make sure you get to one question, just kind of look for me clicking on the question. So we just did this one, and now I'm going to do the next one, recursive sequences level 1. Okay, recursive. And that also says it right here if you're trying to find what question we're on. It's titled this recursive sequences level 1. Okay, I am erasing my board. All right, if A1 equals 3 and AN equals AN minus 1 plus 4, then find the value of A5. Now, again, this is maybe, you know, a lot of notation for you to take in because if you have experience with sequences, then this could be a lot. But I'll try to walk you through it. It's kind of the same thing we just did. A1 just means the first term, right? And it's the same thing. Before we had n, that labeled what term we were on. So n minus 1 would be the value of the term before it. So the value of the first term is 3. We're trying to find the value of the fifth term. All right, and the value of any term is the term before it plus 4. So if I know A1, then A2 has to be the term before it plus 4. Well, what's the term before it? A1. And what is A1? 3. So A2 has to be 7. So far my sequence goes 3, 7. All right, so what would be the next term? A3. Well, what is A3? It's the term before it plus 4. What's the term before it? A2, the second term. What is A2? We just found it. It's 7. What is 7 plus 4? 11. So we see that the third term is 11. Now we can see that common difference here is we're adding 4. So let's add 4 again. That's 15. Let's add 4 again. That's 19. And we're trying to find A5. There it is. A5, the fifth term, is 19. Okay, and they went forth, they went ahead and did it, with the notation each time. If you see the pattern, then, just go ahead and work with the pattern. You definitely don't have to write it this way every time. It's good practice to write the notation and make sure you're understanding the sequence notation, right? So A5, the fifth term, is the fourth term plus 4. So A5 minus 1, this is all in the subscript, right? So let's make sure you're understanding that here. AN, the subscript is N. AN minus 1, the subscript is N minus 1. So this isn't just like, to be really careful, because sometimes when you write this, I see this a lot. And that means AN and then subtract 1, the value of that term, and then minus 1. And we don't want to, we want to make sure you're subtracting the term, going backwards on the terms. So if we had AN minus 3, this would be the term that we're on minus the 3. So let's say in our question, AN minus 3, let's say we want to know the, say we're on the fourth term, AN minus 3 would be A4 minus 3, which is 3 terms before it, which would be A1, the first term, right? So A4 minus 3 is 3 terms before it. Okay. All right, cool. All right, so that was recursive sequence level 1. Let's go to write recursive formula for sequence. All right, so it says write a recursive formula for AN, the nth term of the sequence 3, 5, 7, ... All right. I know you guys can do patterns. I've seen you do that super well. I'm sure you can see the pattern already. It's +2. All right. Now, it's saying to write the actual sequence, right? So it wants us to say, in general, what is each term in terms of the term before it? And that's why it gives us this handy little AN minus 1 button so that we don't have to try to write the subscript. It wants us to make sure we include AN minus 1 in our answer. All right, so I can see my common difference though, right? We're adding 2. And you can think of this kind of like this arithmetic sequence. And this kind of got rubbed off. Sorry about that. AN is the first term, A1, plus the common difference times n minus 1. And this actually doesn't incorporate AN minus 1, so I'm going to make sure we do that. Maybe I'll write that underneath it over here. Okay, so the first term, A1, is 3. The second term, A2, is 5. In other words, 3 plus 2. The third term, A3, is 7. In other words, 3 plus 4. All right, do you see where I'm going? So if I wanted to go on and on and on to AN, I would say it's 3 plus something. A1, our first term, is 3. That's why it asks us over here. A1, what is it? It's 3. Okay, because that's important, valuable information. Now think about the relationship between these numbers here. 0, 2, 4. This is the same as 3 plus 2 to the 0, right? Oh, oops. No, it's not. Sorry. This is, oh, I see what I'm doing. Okay, my fault. Caught myself in my own thoughts there. This is 3 plus 2 to the first power. This is 3 plus 2 to the second power. And now I'm trying to figure out how I'm going to write this as a to the n. A n minus 1. The term before it. Okay, here we go. The second term. Okay. Stuck on my own thoughts for a second. Sorry about that. Because I want to write it like this. And maybe I'll do that first, just so I can get a handle on what I'm doing. Just 3 plus... So I wrote it with the common difference of 2 times n minus 1 is 2n minus 2, which is 1 plus 2n, an minus 1. How do we write it with the term before it? Okay, all right. Well, this is a good way for you to watch somebody problem solve. Okay, what relationship does it have in terms of the term before it? Well, 5 is A1 plus 2. There we go. 7 is A2 plus 2. Okay. Woo! I don't know why that took me so long to do. My fault. All right. What we want to do is incorporate, like I said, this little an minus 1, right? So what we're trying to think about is the term that we're on, the relationship that it has with the term before it. And as we said, the term that we're on is the term before it plus 2. So if I want to write A2, well, it's just the term before it, A1 plus 2. Okay, so AN is the term before it, AN minus 1 plus 2. Okay. AN is AN minus 1 plus 2. Okay. All right, so here's our common difference. That's the thing I was talking about with this here. D is the common difference. And phone call. Okay, and then there we go. We got it. All right. I think I'm going to pull up a new problem just so we can look at that real quick again. And this is a... Oh, good. Let's do this because this is geometric, not arithmetic. So that's a good way to look at it again. All right, 27, 9, 3. So maybe yours looks like this. So maybe you don't have a common difference. Maybe now you have a common ratio. What is the common ratio? It's pick a term and divide the term before it. So if I pick my term is 9 and I divide the term before it, what is that? It's got to be a common ratio. It has to be the same as pick a term, 3, divide the term before it, 9. What is that? Well, these simplify to 1 over 3, right? Each time we're dividing by 3, which is the same thing as multiplying by 1/3. right? Multiplied by the reciprocal. Okay, so how do I write this? Well, an, it wants us to think about the relationship that the term that we're looking for has with the term before it. So every term that we're on is the term before it divided by 3 or multiplied by 1/3. So if I wanted to find the fourth term, A4, well, I would take the term before it and multiply it by 1/3. What's the term before it? A3. What is A3? 3. What is 3 divided by 3? Or multiplied by 1/3? 1. So A4 would be 1. All right, but this is what it's looking for. We could probably just write divided by 3, but all right, A1 is 27, right? First term. So AN is 1/3 times the term before it. Okay. All right, cool. Now I feel like we're on track. All right, getting there. Common ratio difference level 1. All right, find the common difference of the arithmetic sequence. All right, so here we go again. Talking about the arithmetic. So we're finding a common difference. I'm sure you can see the pattern already. All right, what's the pattern? We're subtracting 7. Minus 7, minus 7. All right, now if you wanted to find a difference, what does difference mean in math? Well, it means subtraction. So I take a term and I subtract the term before it, and that gives me the common difference every time. Negative 15 minus negative 8. Well, hopefully that's the same thing as negative 22 minus negative 15. Right, so you take any term and subtract the term before it. What is negative 15 minus negative 8? That's the same thing as negative 15 plus 8, which is negative 7. And that we would get the same thing here. Okay? All right, so our common difference is negative 7. And that's all the question is. Find the common difference. Negative 7. Okay. All right. Find the 77th term of the arithmetic sequence. All right, now we're coming to the case, situation where we're not going to do it by hand. So I'm not going to find, A77. I'm going to have to use the pattern, write the sequence in sequence notation, and then find 77th term. Okay, so A1 is 14. A2 is 3. A3 is negative 8. Okay, so we're going to go on and on and on until we find A77, the 77th term. All right, so what are we doing each time? I'm giving you like a little wait time here. We're subtracting something. And if you can't see it right away, you could always take the term and then subtract the term before it. So 3 minus 14 is what? It's negative 11. So we're subtracting 11 each time. All right. So each term is 11 more than the term after it. Or in other words, like A2 is A1 minus 11, right? A3 is A2 minus 11. So every term, AN, is the term before it, AN minus 1, minus 11. So what is A77? Well, it's... Oh, and this is where I want to use the other formula. Okay. Well, it's A76 minus 11. Again, we don't know A76, right? So that's where I want to use this handy-dandy formula, which is AN. I'm going to rewrite it over here. A1 plus D times N minus 1. All right. A1, so let's do A77. That's what I want to know. N is now 77. maybe I'll write that right here, n equals 77, 77th term is A1. What is A1? 14. Plus the common difference. What's the common difference? Negative 11. Times n. What is n? 77 minus 1. All right, so I can put this in my calculator. 14 minus 11 times 76. Okay, so 14. Oh, my calculator's off. 14 minus 11 times 76 is negative 822. All right, let's put that in. Negative 822. Okay. All right. And there you go. It used that formula right there. So maybe I'll zoom out for you here. These are all handy to use during this assignment. All right, arithmetic sequence. AN, the term that we're looking for is the first term plus the common difference times that term number minus 1. Okay. Maybe you should write that down. Give you a second. I'll leave that right here. And maybe you can write some of these down on the paper that you're working on. I'll pause. All right, we are getting there. We are almost done. All right, nth term of a geometric sequence. That's the one that we're on. Find the 11th term of the geometric sequence. All right, so it's telling us that it's geometric. So I'm going to use my blue marker since I wrote geometric in blue. So here's our sequence. It's 6, negative 18, 54. Dot, dot, dot. All right. It says it's geometric. That means there has to be an R. What is R? Well, it's the common ratio. What's the common ratio? Well, it's a term divided by the term before it. So R equals negative 18 divided by 6. It should also be 54 divided by negative 18, which is what? Well, it's negative 3. You could put that in your calculator. You don't have to just do it off the top of your head if you don't want. Maybe you were given just these two and you didn't know what 54 divided by 18 is. That's okay, because we can put that in our calculator. But so R is negative 3. All right. So AN is A1 times R to the n minus 1. All right. AN, well, we're looking for A11. So you find the 11th term. So we're looking for A11 equals A1. What is A1? 6 times R. What is R? Negative 3 to the n minus 1. What is n? 11. All right, well then just 6 times negative 3 to the 10th power, which is a big number. It's we're going to do that in our calculator. Okay, so we got to be careful. I'm going to use a parenthesis for negative 3. We're raising that to the 10th power. That's this, and then I'm still multiplying by 6. All right, so 354,294. Okay. 354,294. Okay. All right, and it did the same thing we did. It used this formula here for geometric sequence. Okay. Last one, write the explicit formula for sequence. Okay, so it says write, so this is the same thing we were just doing, but now it wants us to write the formula for the sequence instead of finding the value of something. And let's see. I don't know, I'm trying to figure out what color marker I'm going to use. I might just use black so that I don't confuse you. All right, 7, negative 14, 28. I can see that we're not like adding or subtracting a number, right? Because we go from positive to negative to positive, so there's no way this is arithmetic. This has to be geometric because I have a common ratio. And what is it? Well, I'm multiplying by -2 each time. And if you couldn't see that right away, you could do a term divided by the term before it, which is -2. So that's our common ratio. All right, so it's, in here, we're pretty much ready to go. Actually, this is set up just like this. I should have used my blue marker. So AN is A1, which is 7, times R, which is -2, to the n minus 1. And that's it. That's our answer. So AN, I already gave you that part, is 7 times -2. And I have to use this for exponent. 2, I'm going to use parentheses just to be safe here, n minus 1. Okay. Cool. Done, done, done. And I will make a video just like this for remote learning number 2 and remote learning number 3. There's 3 total assignments for your class. This, again, was a step-by-step way for you to accomplish these questions, but obviously they're all situational, and, maybe you need help because of the numbers or, positive or negative or whatever. So let me know if you have any questions. This was 42 minutes, so almost exactly a class period on Mustang Minutes Day. Have a great rest of your day, and I will see you next time.